Okay, here we go. We are working on our final review tutorial together, and we've got a line, which of course is linear. So we're just going to spend the time during this tutorial to review a lot of things. Since the very, very first day, we talked about things that were linear. We talked about how we read a line, or we read graphs from the left to the right, just like we read a book. So when we're reading this from the left to the right, we can tell that it's decreasing. Another way we can tell it's decreasing is if you wrote your name on this line. Woo! My name is going downhill, so that's another way to tell that it's decreasing. Okay, the y-intercept, we're looking for where this line crosses the y-axis, and we see right there. I know that sometimes it was okay to put a -5, other times we wanted it in a coordinate point form. And then the slope, of course, we're going to pick two corner points, and a corner point is one of the corners of all these squares that make up a grid, and there's another corner point. So our slope would be we rise up 1, 2, 3, 4, and we run 1, 2, 3. So we would put 4/3, but then we would stop and say, wait a minute, this is a decreasing line, therefore the slope is negative. Here, once again, we have a line, so it's linear. It is also decreasing. If I were to write my name on this line, it's going downhill. That means it is decreasing. And then for the y-intercept, we're looking for where the line slashes through the y-axis, and it does it right here on the origin, which is 0, 0. And then to find the slope, we want to look for two corner points. We have a lot of corner points here, don't we? The origin's a corner point, there's a corner point, there's a corner point, there's a corner point. Lots of corner points to pick from. And so we see that we're going to rise up 1, where we're going to run over 2. And so we would say it's 1/2, but then we're going to remember, oh, that's right, this is a decreasing line, so the slope really is a -1/2. Okay, then we were exposed to tables from the very, very beginning, and we were asked to find the rate of change, another word for slope. And so we did the hoops, and when we did the hoops, we always said 12 minus 8, so we're always subtracting, is 4, 8 minus 4, 4, 4 minus 0, 4, 0 minus -4, 4. So right away we can stop and say, oh, the rate of change is 4. But wait a minute, we have to make sure that the x's are changing like we want them to change. So let's look at them. 4 minus 3 is 1, 3 minus 1 is 1. All right, this is looking good, right? Because the rate of change really is the change in y over the change in x. So my slope, my rate of change is 4/1. Of course, we can write it as 4. Feel free to stop this tutorial and pause it, and I will be there when you push play again. All right, so a table, and we're going to go ahead and do the hoops. 17 minus 15 is 2. 15 minus 11 is 4. Ooh, something new. They're different numbers. 11 minus 1, 10. 1 minus a -5 is 6. Okay, so before we stop and say, oh, there's no rate of change, there's no constant rate of change, we need to look at the x side of the table. So 8 minus 7 is 1. 7 minus 5 is 2. 5 minus 0 is 5. 0 minus -3 is 3. So when we think about it, if the rate of change is the change in y over the change in x, then the first time we looked at it, we're saying, oh, well, then the slope's 2/1. But then we look at the next pair, and we'd say, well, this rate of change is the change in y over the change in x. That would be 4/2. Ooh, it looks different, but so far, is 2/1 the same thing as 4/2? Yes, they are both equal to 2. And so we move up the table and we notice, oh, our change in y is 10, our change in x is 5, so that's 10/5. Another way to say 2. And then we have 6/3, which is another way to say 2. So all these hoops, when we do them, and then we look at the change in y over the change of x, because, right, slope is rise over run. Slope is change in y's over change in x. And so we see that our rate of change, no matter how you write it, it reduces to 2. Okay, now we're looking at the equation of the line and trying to get information from it. We know it's slope-intercept form. Now, in the beginning of the year, we really didn't, well, I guess we talked about that. So we see it's in y equals mx plus b form. We know that the number that comes before the x is our slope. And so we can right away go, oh, rate of change, which is another name for slope, right, is -4. And we know if slope is negative, that means it's decreasing. And we also know that our number that's by itself, our 5, is the y-intercept. I'm going to write it as a coordinate point, 0, 5. You could also write it as 5. Actually, your final is multiple choice, so you may not have a choice. You're just going to have to pick the one that's either 5 or 0, 5. Okay, same thing here. We notice right away that we have the slope, or the rate of change, of 7. And that since 7 is positive, that means it's increasing. And that when I go looking for the y-intercept, the number that's supposed to be here, I'm like, oh, it's not there, it's missing. Well, whatever's missing is 0, right? Now, I want to stop right now and talk about the difference between that and this. Sometimes when we look at equations like y equals x minus 4, and we say, oh no, where's the slope? And we would say, well, it's missing. There isn't something there. Now, that's a different kind of missing. Okay, when in this case over here, the y-intercept truly was missing. It's gone. There's nothing there. I don't see anything. But in the slope's case, the x is still there. So when we don't see a slope, but we see an x, we say to ourselves, all right, how many x's are there? 1 x is there. That's why y equals 1x minus 4 is the same thing as y equals x minus 4. Now, that's totally different from the problem that we were working on, but I thought I would address that because some students still get confused by that, when to put a 0 and when to put a 1. Okay, so with the linear equations, let's have fun with this. All right, this brings me back to the beginning of the year and school just starting, and we were getting to know each other, and we were circling linear equations. Those were the good old days. So we would go ahead and say, oh, we know anything that doesn't have a square root. So square roots are not linear. Squares are not linear. Things like this. Oh, look at this. It's an equation in standard form. Oh, we can't have x in the denominator. No, no, no. That's not linear. But this is linear. Even though we have parentheses and it looks long and complicated, it's still linear. So I remember when we were doing these, you guys were really good at coming up to the smartboard and Xing out the ones that have square roots or squares or exponents or x in the denominator. Do you guys remember that? Okay, circle the linear equations. Once again, we do better, I think, when we x out the ones that aren't linear. X in the denominator, no. Oh, fourth power, no. Second power, no. X as an exponent, no. All right, let's look at the rest of it. This is nice, a linear equation in standard form. This is one of those linear equations, if we graphed it, it would be straight up and down. And here's a nice linear equation as well. All right, let's do these again. I must have included so many because these are fun. All right, we know anything to a power that's not going to be linear. X in the exponent spot, that's not linear. And second power, that's not linear. So hopefully you had just as much fun reminiscing about the good old days at the beginning of school as I just did. Okay, that's the good news. Remember those first 2 standards and you guys got such great grades right away, didn't have to hardly do any retakes? Well, those standards are going to be part of the final, so that's good. All right, Susan owes her parents $212. She's paying off her debt by babysitting her little brother. Her parents reduce her debt by $6 per hour of babysitting. And it says, does the amount of money Susan owes her parents and the number of hours she babysits represent a linear relationship? And I can just hear you say, yes, it does. And the clue is the $6 per hour. That's our rate. That's our rate of change. So every hour that she babysits, she makes $6, which she can then reduce her debt with if she turns around and gives that to her parents. So that's our clue that yes, it is linear? So we can say yes. And then it says, how much will she owe her parents after 5 hours of babysitting? The great thing about the multiple choice final is that you can do whatever work suits you, whether you want to do this logically or make an equation, however you want to come up with the answer, you can do it. We're not checking your work. So anytime you can figure something out logically and it makes more sense to do it, do it. Let's see, how much will she owe her parents after 5 hours of babysitting? Well, I know that in 5 hours of babysitting, she worked $6 each hour, so she made $30. And we're assuming here that she takes every penny that she makes babysitting and she uses that to reduce her debt. So she's going to have what, the 212 minus the 30, and what's that going to give me? I'm not having a calculator here. 11 minus 3 is 8. So she'll have her, she'll still owe her parents $182. Okay. You could also have made a table with that if you wanted to. All right, St. Louis Police Department pulled over 5 people for speeding today. A 16-year-old was driving 15 miles per hour over the speed limit. An 18-year-old was driving 10 miles per hour over the speed limit. And a 26-year-old was driving 9 miles per hour over the speed limit. Does the relationship between age and miles per hour over the speed limit represent a linear relationship? Okay, this says show why or why not. Obviously, you can't show this on a multiple choice Scantron. So it's all about figuring it out and picking the right answer. Here's the tricky part of this. I see miles per hour, and that's a rate, isn't it? And so if it said that everybody was going the same rate over miles per hour over the speed limit, then we would go right ahead, go, oh yeah, this looks linear. They all have the same rate, but they all have different rates. So what we're forced to do is we're forced to make a table out of it so we can make sense out of our data. So I'm going to put age on this side and miles per hour over on this side. Once again, on the final, you don't need to do all this labeling. You just need to make a table that makes sense for you. So we've got the 16-year-old going over 15 miles per hour, 18-year-old going over 10, and a 26 going over 9. Let's see, let's do the hoops and see what we get. 9 minus 10 is -1. 10 minus 15 is -5. 26 minus 18 is 8, and 18 minus 16 is 2. I don't think so. If we did the rate of change in y would go on the top, over the change in the x's would go on the bottom, and then we'd have to do it again. Change in y would go on the top, over the change in x. Do you think that -1/8 is the same as -5/2? No. And if you're not sure, you could always put -1/8 in your calculator and change it to a decimal, and put -5/2 in your calculator and change it to a decimal, and then compare the decimals. But no. -1/8 is not equal to -5/2. So that means that no, it doesn't represent a linear relationship. Okay, the population of Maryland Heights is decreasing at a rate of 5% each year. The population of Maryland Heights was 32,000 in 2010. Does the way the population changes over time represent a linear relationship? Why or why not? Okay, now here's what's tricky about this one. We see a rate, right? We see decreasing at a rate, but then we notice that the rate is 5% each year, which means if we were to sit and do this, that if we started out with 32,000, we'd have to multiply 32,000 times 5% in the calculator. I'm going to put times 0.05, and we'd get a number. I don't have the calculator right now. Okay. And then we would take that number the next year, multiply that number times 5%. Each year, we would be multiplying a different number times 5%. That's not a constant rate of change. And then we probably remember we said whenever percents are involved, that is not linear. We'll find out next semester what it is, but it is not linear. No. Remember writing, I remember on this test I said, okay, you got to make a table, do one hoop, and then put no, percentages are not linear. There you have it. We're seeing it again on the final, right? All right, here we go, graphing. And now that we've done systems of equations and we've done writing equations of lines, we look back at something like graphing and it should seem really easy. Y equals 5, we go to the y-axis, we find the 5, and we draw a line straight across. Hopefully you can remember me saying, holding my arms out straight parallel to the floor, saying, why, oh why does y equal 5 look like this? Okay, graph this. This is our cover-up method, which we've talked about. Cover-up method says, well, wonder if x is 0. This would go away. We could cover it up, and we'd have negative 4y equals 12. And we'd go ahead and solve for y. And we're good at this because we just did all this stuff on our systems of equations test, right? So we go to the y-axis, and we find the negative 3, and we put a dot there. What we just found was the y-intercept, right? Every point on the y-axis has a value for x equal to 0 and a different value for y. So now we're going to find the x-intercept, and that means, wonder if y, we set y equal to 0. Well, 0 times negative 4 is 0, gone. We're going to cover it up, and we end up with 2x equals 12. And when we solve for x, we're going to divide 2 on both sides, and we get x equals 6. We go to the x-axis, we find the 6, because that's where this line goes through the x-axis. It's its x-intercept, and we connect the two dots, and there you have it. Now, on the final, you're not going to be able to graph, but what you will be doing, sorry, I'm checking the time, what you will be doing is picking from 4 different graphs and finding the graph that we just graphed. Okay, once again, also cover-up method. If I cover up my x, I end up with 2y equals 6. I'm going to solve for y, and I get y equals 3. So I go to the y-axis, I put a dot on 3. But then I could also cover up the y term, and I would get x equals 6. Whoa, don't even have to solve for x. There it is. Go to the x-axis, put the dot on 6, connect the dots, and you got it. That's our line. Graphing again, we learned that we need to distribute first. So we went ahead and distributed 2 times x is 2x. 2 times negative 1 is negative 2. Please don't be that person that forgets to distribute the 2 to that second term, to that negative 1. It's really easy to forget, but please don't let it happen to you. Then we're going to combine like terms. Negative 2 plus 3 is 1, 2x plus 1. So this is in slope-intercept form. Here's my y-intercept. So I look at the y-axis. I put the 1 there. This is my slope right here, which if it's 2, that means up 2 over 1. Whenever we have a whole number as a slope, we remember to put 1 underneath it. If we don't run, we're just going to go straight up and down, and that's not going to be the correct graph. I'll do that one more time and connect the dots, and there you've got it. Okay, your parents deposit $100 into an account for your morning coffee. You get a vanilla iced coffee every morning that costs $5, including tax. The equation 5x plus y equals 100 represents the amount of money y in your coffee account on any given day x. So label each axis of the graph to go with the situation described, and then graph it. All right, so money, days, right? Is that what we've got? We always talk about what does it mean, IV, DV, when you do that in science, independent variable and dependent variable. And we talked about in class how time waits for no one. Time is independent. It just keeps ticking. It just keeps going no matter what we do. We can't stop time. And so that's why, the x-axis, when we think about, the table, the xy table, the x always stands for the independent variable, because x can be anything it wants. Y is just waiting to see what x is before it knows what its value is. All right, I'll quit rambling, though. It's good rambling. Days, time is always going to be represented on the x-axis. And then money is usually always represented on the y-axis. So depending on the day, we can read the chart or read the graph to see how much money. So here we go. I'm going to look at 5x plus y equals 100, and I realize, I can do the cover-up method. I can cover this up, and that tells me that y equals 100. So that means I go to the y-axis, and I see 100, and that's where I'm going to put my dot. Or I can do the cover-up method and find my x-intercept. So I'm going to cover up the y, and I'll find that 5x equals 100. I'm going to divide both sides by 5, and I'll get x equals 20. So I'll go to the x-axis. I'll put a dot on the 20, and then I'm going to connect the dots. Notice when we're doing applications, when we're doing context problems, that's not really a straight line, but we don't go extending it off to both sides because it wouldn't make sense. It wouldn't make sense to have negative days or negative money. Well, negative money more than negative days. So we're going to stop here. And then it asks us, okay, what's your y-intercept? Well, depending on how it's stated on the final, you could either put 100 or you're going to see it as a coordinate point 0, 100. And what does the y-intercept mean? Well, if we look at it on the 0 day, no, what's the 0 day? Before things started, in the beginning, initially, you had $100 in your account. So we could put initial amount of money. Now, once again, you're not going to be able to write on the Scantron, so you'll have to look for the best multiple choice answer to pick. And then the x-intercept, we see that that's 20. I'm going to go ahead and write it as 20, 0, because that's its name as a coordinate point. And what does that mean? On the 20th day, oh my goodness, look what it matches up with. $0. So we could say on the 20th day you ran out of money, 20th day you had 0 in your account. Either way, on the 20th day, it's bad, sad news. No more coffee. Okay, write the equation of the line. Now you can tell we just zoomed through our first two units that we did this year, linear functions and linear graphs, and now we're moving on to the third unit we did together, which was writing the equation of lines. And so I love these, don't you, where they give you the y-intercept. It is clearly -4. So I'm going to write that the y-intercept is -4. And what else can I clearly see? I'm hoping that your copies were made clearly, that you can actually see these corner points. So I see a lot of corner points. I'm going to stop. The slope, of course, is going to be the rise 1, 2, the runs 1. So my slope is 2/1, but I'm just going to write a 2. And I'm done. When I know the slope and the y-intercept, I'm going to use my y equals mx plus b form. I'm going to put the 2 in for the slope, and I'm going to put the -4 in for the y-intercept. Okay, write the equation. Another great one, right? They give us the y-intercept, and the y-intercept, the letter we use for it is b, and the y-intercept is 0. And then we look for corner points, and we see that our slope is what, down 1/2. So I'm going to put 1/2, and I'm going to remind myself, if I wrote my name, I'm going downhill. It is negative. It is a decreasing line. So I'm going to put it all together into my slope-intercept form. I'm going to put in -1/2 for my slope. And 0, I could write a +0, but I'm not. People will know when the y-intercept's not there that it is because it's equal to 0. Okay, write the equation line. This is awesome. If y's are horizontal, then y equals a number is horizontal when you graph it. Then x equal a number has to be the opposite. It has to be vertical. So I look at the x-axis. I see what number it's going through. It's going through x. I'm sorry, it's going through 3. So x equals 3 is the name of this line. All right, so, this is a bummer. This is one of these lines. Can you see that we cannot see the y-intercept clearly? And so that means that we're forced to find 2 corner points. So let's go ahead and do that. I believe there's a corner point and there's a corner point. And so what I'm going to do is I'm going to use these 2 corner points to find the slope first. And I see that I rise up 1 and run over 2. So we rise up 1 over 2. So our slope is going to be 1/2, and that's good because slope is very, very good to have when you're graphing. And now I have to pick a point because as soon as I see that I don't have a y-intercept, I know I've got to use that long formula that we call the point slope, and it looks like this. Everyone's favorite formula. All right, so we already have the slope. That's good. Now I need to find h comma k. And what h comma k is, it's just a point. So I'm going to pick one of these points. This point looks good enough. I'll use this. It's over 1, 1, 2, 3. This point's name is 1 comma negative 3. So I'm going to use that. And then it's just about plugging and chugging. So here we go. I see a y, I write a y. I see an equal sign, I write an equal sign. I see slope, I'm going to write 1/2. See a parenthesis, write a parenthesis. I see an x, I write an x. And this is very, very, very important. I see a negative sign or a minus sign. We can interchange those two words. I'm going to write it. Okay, now and only then, after I've already written the negative sign or the minus sign, do I start substituting. I see an h, I'm going to substitute in for that a 1. I see a parenthesis, I write a parenthesis. I see a plus, I write a plus. I see a k, I plug in for the k, negative 3. Now, I know, right? I could have done, instead of plus negative 3, I could have just done minus 3. It's okay. Either way, it'll all work out. All right, here we go. Let's distribute. And of course, we will remember to distribute to that second term. 1/2 times negative 1 is negative 1/2. And then I will say the plus negative 3, that's going to be just a minus 3. I'm going to put that into my calculator, negative 1/2 minus 3, and it will give me negative 3.5 or negative 3.5. Either answer, well, actually, either answer will be correct, but you'll only find one form on the final. One of the answers to choose from will either be in decimal form or in fractional form, but you guys can figure that out. Okay, wonder if we were just given 2 points. Well, we're going to have to decide which formula to use. All right, first of all, on the final, this would be the only part that they would ask you. They would not do and step 1 and step 2. So these are here just to remind us of what we did when we were preparing for writing equations of lines test and actually taking the test. So of course we're going to use the long formula, the point slope formula that looks like this that we just talked about. And that means that we need to find the slope. And how I taught it in class is they give you 2 points, then go ahead and write the points down in table form. So when I see 2, 5, I'm going to write a 2, 5 because this is my x and this is my y. And when I see 4, 9, I'm going to write it here. And why do I do that? Because this, for me, is an easy way to find the slope. If you've got it in table form, you just do the hoops. 9 minus 5 is 4. 4 minus 2 is 2. And the slope is always going to be the change in y, so this number on this side, over the change in x is this number on this side. So what's 4 divided by 2? 2. So our slope is 2, which is great. Now we pick a point, either 2, 5 or 4, 9. I'm one for picking 2, 5. It just looks a little easier. So we've got our slope, we've got our point. Let's plug it all in. Here we go. So instead of m, I'm going to plug in my 2, plug in everything else. There we go. I'm going to move my slope over. Oops. Okay. Move that over so we have some room, and we need to distribute. And remember to distribute to the second term. Okay. Then we're going to gather our like terms. Do you feel like you could do this in your sleep? I think we've gotten so good at it that some of us could do just that. That would be a good dream. All right, write an equation of the line that passes through the points 5, 4 and negative 2, 4. Hallelujah, we do not need to do a table, do we? Because what do we notice right away? For this point, y equals 4. For this point, y equals 4. What do you think the name of this line is? The name of this line is y equals 4, and all the points on this line have 4, where the y value is in the coordinate point. So that's pretty cool. Write the equation of the line that goes through the point 1, negative 3 with slope equal to negative 2. This is a little bit easier than the problem we did, not last problem, but the problem before, because we know we need to use this form. Do you need to have this form memorized for the final? Yep. All right, and they just gave us all the information, right? They gave us our h, they gave us our k, and they gave us our slope. So now all we need to do is plug it all in. So we're going to distribute, of course. Bring down the -3. We're going to combine our like terms. And there we have it. Do a little time check. Okay. Here we go. Write the name of the line represented by this table. Sometimes we're going to see tables laying down. And I don't want you guys to freak out if you see that on the final. If it bothers you, you can always rewrite it. And basically, see how they have input? When you see input, that's always the X. When you see output, that's always the Y. So instead of having it this way, they kind of took it and flipped it and laid it down. So we just have to be really careful. We can still do our hoops. We can still say 13 minus 10 is 3, and 10 minus 7 is 3, and 7 minus 4 is 3, and 4 minus 1 is 3. We can still do our hoops up here. But when we're done with our hoops, because that hasn't changed, when we're done with our hoops, we still need to remember who gets put on the top in the numerator. And the change in y goes on the top. So that means the 3 goes on the top, the 1 goes on the bottom. So we know that my slope is 3. Let's pick a point. You want to pick 1, 1, 2, 4? Let's just have a little fun and pick 1, 1. So once again, we're going to write down the equation that we know by heart, and we're just going to plug in, right? The 3 goes where the slope, the 1 goes where the h goes, and the 1 goes where the k goes. So we're going to plug it all in. Oops. I was just going to keep writing 3s. All right. 1 and a 1. And please don't forget to distribute. So we're going to get 3 times x is 3x. 3 times -1 is -3. Of course, when we distribute, we're multiplying, right? We're going to gather like terms. -3 plus 1 is -2. What is the name of the line that's parallel to y equals 3x plus 5 and goes through the point 2, 7? Well, we know that if two lines are parallel, that means that they have the same slope. So when I taught this, remember I said, okay, this is the old line. So the old line is y equals 3x plus 5. And we're going to, from the old line, we're going to steal the slope. We're going to steal it. This is for the new line. We're stealing the slope. And then we throw the old line away. We just throw it away. We're not going to look at it anymore. We stole your slope, and we're throwing you away. That sounds like we're really mean mathematicians. But that's what we have to do, guys. Sorry. And then this is our new point, because we want to find a line that has a slope equal to 3, so it can be parallel to the old line. But that also goes through the point 2, 7. So once again, we find ourselves doing the same thing. We turn to the same equation, because whenever we're given a slope and a point, we use this equation. So here we go. We're going to plug things in. We're going to distribute. 3 times x is 3x. 3 times -2 is -6. We're going to write the 7. And -6 plus 7 is +1. Feel free, once again, to pause this video at any time. I'm kind of flying through it, aren't I? We're 30 minutes in, and yeah, I'm going to try to fly through it. So if you need to slow it down, slow it down. Okay, find the line of best fit. So basically with this one, guys, we're just going to be looking, since we've got multiple choice, we've got answers to look at. We may, when we do this problem, just look and see which equation makes the most sense. In fact, we may spend time looking at each equation and graphing it, and to see which one is the best line of the best line of best fit. All right, so, but if it weren't multiple choice, we would do what we've been doing in class when we did this. Let's see. I'm going to try to get, let's see, how about, okay, that's a stinky line, isn't it? Can I change my line? How about, no, that's even worse. All right, let's see. I'm going to use my straight line thing. So let's see what I could do. If I start here, let's see if I can get, is that a decent line? Because I think I can get 2 corner points that way. It's not the best line of best fit, but it's okay. So anyways, I pick my 2 points. I can see that I have a corner point here, and I have a corner point here. And so how I taught you guys in class was I said, write your corner points. So this point is 16 for the x value and 300 for the y. And this point's name is 22 for the x value and 500 for the y. Yes, we have a graph. Yes, we could do rise over run, but the reason why I don't say to do that is because the y-axis is going up by a value of 100 with each tick mark, and the x value is going up by 2 with each tick mark, which means that if you forget your scale, you may end up doing rise over run getting the wrong slope. So let's just do it with the table. All right, we're going to do our hoops. 500 minus 300 is 200. 22 minus 16. Let's see, is that 6? Yep, that sounds good. I'm doubting myself now as the day is progressing. So I've got 200 divided by 6. I'm going to reach over, finally, for a calculator. And let's see what this is. This is 200 divided by 6. And that gives us 33.3. I am going to take the wimpy route, and I am going to simplify that, or round rather, to 33. So then I am going to use 33, and I'm going to pick one of the points. How about 16,300? And plug it all into this formula. I think the whole goal here with this writing equations of lines was that we were going to have to practice so much using this formula that we would get so tired and we would just say, just give me the test already. I don't want to write this formula down one more time. Hopefully all of you are done with your writing equations of lines retakes. Let's see. So we're going to start plugging things in. We've got 33. We've got x minus 16. We've got plus 300. I'm going to have to pick up my calculator again. All right, what's 33 times 16?
Any students involved in Black History Month? They are practicing in Ms. Harris's room right away.
Okay, you heard that. All right, so then we're going to have 33x, and we're going to have what? Minus 228. Does that look good? Okay. So it's kind of crazy because when we look at this graph, we can't, if the y-intercept is negative 228, and we're used to seeing our y-intercepts here, that's not negative 228, but neither is this 0. All right, so that's that with the line of best fit. Let's go back to it. If we took this x-axis and we extended it to the 8 and the 6 and the 4 and the, whoops, lost it. This line would also continue to go, go, go. Can you see how it's heading down into the negatives? And so having a y-intercept of negative 228 isn't all that unrealistic. That's pretty realistic. All right. 10 times as many girls and boys received tweets from Katy Perry. I made that up. At any given time, complete the table with possible combinations of girls and boys. Write an equation that represents all the possible combinations. So if one boy receives a tweet from Katy Perry, how many girls received a tweet? That's right, 10. 2 boys, 20 girls. 3 boys, 30. Okay, can we see what the slope is here? I mean, it tells us, right? 10 times as many. So we know that our slope is 10, and we can pick a point. Why don't we use 110? We're going to plug it into our favorite formula. Oops, let me write down the formula. I'm just plugging in and writing down at the same time. Okay, so we're going to start plugging all our information in. We're going to distribute. And look what happens. We've got negative, when we combine our like terms, we've got negative 10 plus 10, which cancels out. And the answer to this equation is y equals 10x. If you can tell that this equation would be y equals 10x without doing all of that work, go for it. It's a multiple choice final, and if you can use logic, like I said, whenever you can, use it. Okay. Macy is going to the movies with friends. She has decided to buy popcorn and candy for the whole group. Popcorn costs $4 and candy costs $2. Write an equation that represents the possible combinations of how many of each she can buy if she has $50 to spend. What I love about this is we've done these types of problems in the system unit, and the system problems were a lot more difficult. So this is going to seem really easy. Popcorn costs $4, so that's 4p. Or depending on what's written on the test, on the final, you could see popcorn instead of p, you could see it as an x. Candy costs $2. We're buying both of them together and spending $50. Voila, we're done. Well, with that problem. All right, Josh's bearded dragon lizard grows 0.25 inches per month, and after 8 months, it is 16 inches. Write an equation that represents the relationship of the total height of the lizard and the number of months. You should probably say the total length of the lizard, because I have two bearded, well, my kids do, and they don't stand up, so they really have a length versus a height, right? Okay, so I'm getting nitpicky because I'm continuing to do this tutorial. Okay, so we've got a rate, right? 0.25 inches per month. That's our slope. That's our rate of change. And then they give us a point. After 8 months, it grows 16 inches. That's a point. The time goes first, 8 months, and the distance or the measurement goes second at 16 inches. And yes, you've got it. We are writing that equation again. Y equals m x minus h plus k. We're plugging in our slope. We're plugging in our 8 for h and our 16 for k. And it said we had to write it in slope-intercept form. So, yep, we've got to distribute. Let's see, 1/4 of 8 is 2. We've got to gather like terms. And there you've got it. It costs $185 for a 2-month country club membership and $457 for a 6-month membership. Write an equation that represents the relationship between months and the total cost at the country club. All right, so once again, we're going to notice that they give us 2 points. They tell us that it's going to cost $185 for 2 months, but we are clever. We are not going to write 185, 2, because remember, time goes first. And for 2 months, it's going to cost us $185. For 6 months, it's going to cost us $457. And so what we're going to do is we're going to find the slope, and the best way to do that is set them up in their table and pick up your calculator. So we'll have 457 minus 185. So it's 272. And 6 minus 2 is 4. And our slope is going to be the change in y. So this side, the 272 over the 4. So let's find out how many times 4 goes into 272. Oh my goodness, it goes in evenly. So our slope is 68, and then we're going to pick one of our points. Let's see, we're going to use the slope. Let's use this point. Let's put it all together. So we'll have y equals 68 times x minus 2 plus 185. We're going to go ahead and distribute. So we'll have 68x. 68 times negative 2 is negative 136. And then we're going to combine our 2 like terms. And we'll have 49. now moving on, after we took the writing equations of lines test, we moved on to solving equations, the solving equations unit. And I just included a few here because we've had to do so much solving equations for systems. I know that we can do it. So let's just look at some of the more difficult ones on this test. I put the DC-GAM here just to remind you, if we can distribute, we've got to distribute first. That means ignoring the 7x. So you kind of put your hand over it, rewrite it, and go straight to distributing. 3 times 5 is 15. That's a positive 15. I've got to put something between the 7x and the 15. If you distribute and it's a positive number, put that plus to the left of it if there's something, another term to the left of that. 3 times negative x is negative 3x, and then I rewrite the negative 4x. I bring down the equal sign, I bring down the 11. The second step is combine like terms, and I do have like terms. I have 7x minus 3x minus 4x. Oh, something very exciting is happening. 7 minus 3 is 4. 4 minus 4 is 0. They're gone. They all cancel each other out. The x's have left the building, and we have left 15 equals 11. Is that true? No, it is not true. When we answer that question, is that true, with a no, that means there's no solution. There's no x out there that's ever going to make 15 equal to 11. Okay, once again, DC-GAM, we're going to distribute first. So 8 times x is 8x. 8 times 2 is 16. And I'm going to rewrite the rest of the problem. And then step 2 is always combine like terms. That's what the C stands for. So the DC part of DC-GAM is distribute. That's the D. The C is combine like terms. So what kind of like terms do we have? Well, I see an 8x here and an x here. It's like I see 8 cookies and another cookie. Put them together. We've got 9 cookies. Got 9 x's.
Lexi Dixon, Sydney Hill, Alva Hall.
Okay, so
Brad
these
Williams.
obviously are going to be special problems here because my next step, let's see, DC-GAM, gather your x's together. So if I want to move this 9x over to the other side of the equal sign, I have to do the opposite, so I have to subtract. And when I do that, crazy, both the x's cancel out. I end up with 16 equals 16. Is that true? Does 16 equals 16? Yes. So the answer is infinite solutions because 16 does equal 16. All right, let's cross multiply. Before we cross multiply, do you remember when I taught this? And I said, please, when x has company, put some parentheses up there. So I've got to do parentheses before I cross multiply. So I've got 2 times x plus 2, and I've got 8 times x minus 1. So I'm going to go ahead and distribute. Then I'm going to combine like terms, but there aren't any like terms to combine. So I'm going to move on to gathering my x's together. So I'm going to move the 8x over. So 2x minus 8x is negative 6x. Now I'm going to, let's see, I'm going to get rid of my 4. So the DC-GAM, let's see, we distributed, we can do the G part, we can gather like terms. We did do the, let's see, we didn't combine, combine like terms, we didn't do that. But we did gather our x's, so we did the G part. The A part is add or subtract. So we're going to subtract 4 from both sides because we want to move it away from the 6, or from the negative 6x. So we do, that's gone. And then the last DC-GAM, the M stands for multiply or divide. So the negative 6 and x are being multiplied together, and the opposite is division. So we're going to divide both sides, and we get that x is equal to 2. I know since we've been doing systems, I really felt like, okay, now we got to take the 2 and plug it back in. I'm like, no, no, no. We don't have 2 equations, we just have 1. It's a nice relief, isn't it, that with solving equations, when we're done, we're done. Not so with systems. All right, the triangle shown in the diagram has a perimeter of 24. Solve for x. I'm going to check on the time real quick. Okay. Perimeter means we're adding the sides together, so that basically, well, not basically, it means that we're going to add x plus 3x plus 4x minus 8, and that equals 24. So I'm going to gather like terms. I'm sorry, I'm going to combine like terms. X plus 3x is 4x, plus another 4x is 8x. I'm going to get rid of the 8 by adding. And I'm going to divide both sides by 8, and that's going to give me x is 4, and I am done. Michael's selling snacks to pay for a new video game. Each snack sells for $1.25. He paid $32 for all of the supplies. How many snacks does he need to sell to make a profit of $75? So what I like to do with these is put an equal sign and decide what I'm doing on either side. And so to the left, I'm going to write all the ways he can make money. So each snack sells for $1.25. This is the only way he's making money. He's selling snacks. So we don't know how many snacks he's going to sell. That's why we're going to put the X there. But we know that each snack he sells, he's going to sell it for $1.25. He doesn't make $1.25, but he sells it for $1.25, right? The revenue coming in would be $1.25 per each snack. Now, how much does he have to earn? Well, he wants to make a profit of $75, but to make a profit, he also has to pay back the $32 that he used to start this whole little business that he's doing. So that's the 32 goes on this side. So many of you want to put it on the left side. No. If you put it on the left side, you're saying, oh, and then somebody came by when Michael was selling snacks and gave him $32. I think not. That did not happen. All right. So let's go. 75 plus 32, that's going to be a 7. That's going to be 107. And then we're going to solve for x. And we've got x equals, do the 107. Turn on my calculator, that might help. Okay, so the 107 divided by the 1.25 equals 85.6, which leaves us with, can Michael sell 0.6 of a snack? No, he's got to sell a whole snack. And since he has to clearly sell over 85, that means we're going to round to 86 snacks. Corey has $250 in his wallet. He plans on getting one pair of jeans and a few t-shirts from Express. The jeans are $85 and the t-shirts are $25 each. How many t-shirts can Corey buy in addition to his pair of jeans? Okay, so let's see. He's got $25 in his wallet, so we'll put the equal sign, and we know he's got that much to spend. Okay. And he plans on getting one pair of jeans. The jeans are $85. Okay. Let's put, he wants to, let's do the opposite way. I'm going to put the 250 on this side. What he has to spend is going to be on this side. And on the other side, let's do all the things he wants to buy. So he wants to buy one pair of jeans. That's going to cost him $85. And he wants to buy t-shirts. The t-shirts are $25, and we don't know how many he can buy because we haven't solved the problem yet. So there we go. He's got $250. He's going to buy $85 jeans and $25 t-shirts. Let's go and solve it. Once again, if you can do this problem logically, go for it on this final. You don't have to show an equation. You can just figure it out using your beautiful math mind. All right, so that's 165, and then we're going to go ahead and divide both sides by 25, which equals 6.6. Question, can he go up there and put his pair of jeans on the counter, put his 6 shirts, and then take the 7th one and rip it so that it's a 0.6 t-shirt, put it on the counter and say, okay, I got the money for all this. You can't buy a 0.6 t-shirt. So in this case, we're not going to round up and say, oh, you know what, it's okay, Corey, buy 7. No, he doesn't have the money for 7. So in this case, we have to round down. Corey almost had enough for 7, but he really could only afford 6 t-shirts. Okay, and then the last thing with solving equations was the literal equations. And so here it says solve for k, and we are simply going to isolate k by dividing both sides by everything that's not k. Okay? Ha ha ha. It's a little k joke. So we're going to have L over 1/2 pi p cubed. You may, let's say if this were on the test, you may see it, the answer like this, and try to figure out why these two answers are the same. All right, moving on. After our solving equations test, we moved on to linear inequalities, and we talked about writing inequalities like Miss Overby will eat at least 45 dark chocolate chips today. No, not today. I didn't have any. Okay, so we know that there's going to be an x, and we know that there's going to be a 45, and we have to decide what goes in between the x and the 45. Okay, if I'm going to eat at least 45 dark chocolate chips today, that means that I could eat exactly 45 chips, or I'm going to eat more than that, right? We read this as x is greater than or equal to 45. If I'm going to eat at least 45 dark chocolate chips today, then I'm going to eat either 45 chips or more than 45 chips. And when we graph it, we're going to put a filled-in circle and shade to the right. All right, bearded dragon lizard's length, well, the bearded dragons are back again, can measure at most 24 inches. So when I think about how to write it, I think, okay, I've got an x on one side and a 24 on the other. And I think, can bearded dragons measure more than 24 inches? No. Can they measure equal to 24 inches? Yes. So they can be equal or they can be less than. So I'm going to find the 24 on the number line. I'm going to fill in the circle. And since it's less than, I'm going to shade to the left. All right, Sean can jump no higher than 4 feet. So once again, I'm going to put let's get a different color. I'll put the x on one side and the 4 on the other. No higher than 4 feet. Okay, let's think about this. Can he jump 5 feet? No. Can he jump exactly 4 feet? Yes. So he can't jump higher than that. So he's going to either jump, his highest jump is going to be 4 feet, and then it might be 3 feet, 3.5 feet, 2 feet. Okay, so x is less than or equal to 4. When we graph that, we put a 4 here. We fill in the circle, and we shade to the left. All right, with this, it's just like solving an equation, except for we have an inequality, and we have to remember one important rule. When we get there, we'll talk about it. So I'm going to subtract 5x from both sides, just like I would if this were an equation. I'm going to subtract an 8 from both sides, just as I would if this were an equation. Now, here's the part that gets tricky. I'm going to get rid of that -2 by dividing it. And I have to remember, every time I divide both sides by a negative, every time I divide both sides of an inequality by a negative number, the sign flips. Or if I multiply both sides by an inequality, the sign flips. So it doesn't affect this. 12 divided by -2 is still going to be -6. Okay, that doesn't change. That's always going to be true in math. But what happened was, because I divided both sides of this inequality by a negative number, my sign went from a greater than to a less than. The same thing happens if we multiply on both sides. And so we're going to go ahead and graph it. There's no equal sign underneath, so it's an open circle. And we shade to the left because it's less than. Okay, let's go ahead and get our x's together. I'm going to subtract x from both sides. So I'll get that's -3x minus 5. I'm going to add 5 to both sides. So, oh, this is pretty. Okay, I added 5 to that side. And I need to add 5 to this side. Still not pretty. All right, so let's see. -3x is greater than 14. That's a really bad attitude, isn't it, Miss Overby? Just because it's not an even perfect whole number doesn't mean that it's not pretty. Of course, it's beautiful. All right, so here we go. Oh my goodness, I divided both sides by negative. I've got to flip that. And I've got x is less than negative 14 thirds. If you want, you can change that to a decimal. I'm not going to right now. I'm just going to leave it as negative 14 thirds. Open circle, shade to the left. Oh, I was trying to make it in under an hour. I'm not going to make it, am I? Okay, here's an and. Let's go ahead and solve for x. Let's divide both sides by 8, and we get x is greater than or equal to 3. Divide both sides by 5, and we get x is less than 8. And let's put them together. I see the 3. Remember, whenever we have two parts to an inequality, because then it's called a compound inequality, the first thing we want to do when we solve for x is we want to see which one's the least, the lesser number. And 3, of course, is less than 8. So we'll put 3 on the left side. We'll put 8 on the right side. I don't care about the scale for right now. Since there's an equal sign here, I'm going to fill in the circle. There's no equal sign here, so that's open. This says x. Now, don't be fooled. This says x is greater than or equal to 3. Always read your inequalities from the variable side first. It says x is greater than or equal to 3. So we're going to go ahead and shade to the right. We're going to stop and we're going to check in on what it says about the 8. It says x is less than 8, which means we're going to go this way. And that's why we use an and, because x has to be both greater than 3, greater than or equal to 3, and less than 8. It has to fulfill both requirements. Here's another one, and we learned that we're going to pretend like we don't have one side of it. Like we're just going to say, oh no, we don't really have this side. We're just going to solve this. And we're going to say, okay, if we were just to solve this, what we would do first, we would add 4 to both sides. But then we're like, oh, we actually do have this. So we're going to have to add 4 to this as well. And the same thing continues. We're going to get rid of the negative 2 by dividing. Oh, alert, alert, alert. I just divided by a negative. So what happens when we divide by a negative? Our signs, both of them, are going to flip. So we end up with negative 11 and negative 21. Now, before we go graph this, we have to ask ourselves, look at two answers. Who is smaller, negative 21 or negative 11? And the winner is negative 21. Even though it looks bigger, because 21 is bigger than 11, negative 21 is even further to the left from 0 than negative 11. So we're going to put negative 21 to the left and negative 11 to the right. And let's stop and look what this says. This says x is less than or equal to negative 11. So I'm going to fill this in, less than's to the left. And then it also says x is greater than or equal to negative 21. So I'm going to fill that in. Since it's an and, it has to be both greater than or equal to negative 21 and less than or equal to negative 11. Okay, we've got an or. So I'm going to go ahead and subtract 2 from both sides. I'm going to divide. Oh my gosh, all this dividing by negatives. Warning, warning, we're dividing by a negative. Okay, we're going to add 12. We're going to get negative 3x is greater than or equal to 12 minus 3 is 9. Oh my goodness, dividing again by a negative. Our sign flips. That's negative 3. So this is an or. So ors usually look a certain way. The first thing I want to do is say who's smaller, 2 or negative 3? Why? Negative 3 is smaller. So let's put a negative 3 here. Let's put a 2 here. And it says x is less than or equal to negative 3. So that means I'm going to fill in the circle and shade to the left. And then this says x is greater than or equal to 2. So I go to the 2, I fill in the circle, and greater than is to the right. And this is what ors usually look like, shadings that go both ways, the opposite way. I'm feeling like I'm close to the end. Let's see, 1, 2, whoo, 2 more and we're done. All right, absolute value. Remember, absolute value means the distance from a number to 0. So when we see that this absolute value on the left is equal to 12, that means the number, whatever the value ends up being on the left, is either 12 away from 0 because it's at positive 12, or it's equal to negative 12, because negative 12, think about a number line, negative 12 is also 12 away from 0. So that's why we're going to have two equations and two solutions for the equation. So we're going to go ahead and add 6 to both sides, and we'll get 2x equals 18. We're going to divide both sides by 2, and we get that x equals 9. So that's one of our answers. If we plug 9 in, we'd get what? 18 minus 6 is 12. Absolute value of 12 is 12. And then on this side, we're going to go ahead and add the 6 again. Divide by 2. And we'll get x equals negative 3. If we plug negative 3 into that equation, we would get negative 6 minus 6 is negative 12. And the absolute value of negative 12 is 12. So these are our two answers. And yes, is it true? Is this our last one? Yay! All right, before we can set up our two equations, we have to get the absolute value all alone on the left side. And to do so, we've got to divide both sides by negative 9. Then we've got the absolute value alone. So that's going to equal what? 30. Then we say to ourselves, okay, whatever the value is inside the absolute value, we know that it lies 30 away from 0. So that means that either the stuff inside the absolute value lies at 30, is equal to 30, or the stuff inside the absolute value is equal to negative 30, because both 30 and negative 30 are 30 away from 0. And so here we go. Let's solve. So we get 2x equals 34, and x equals 17. And then on this side, we've got 2x equals negative 26, and x equals negative 13. So there you have it. We are done with our final review. I'm so proud of us. You'll note that I do not have the systems unit included on this review because we just finished systems and we rocked systems. So proud of you guys and all the work that you've done this semester. You've been a great group, and please, 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 please study for this final. You want to get the highest grade that you can because you don't want to have had an A all semester and then have your final pull your grade down. Same thing with obviously even B's and C's. The higher you can do on your final, the better your grade's going to be. So have fun studying. Thanks for joining me.